Hello, Ketan. I'm audible.
Yes, sir.
Ketan, I'm sharing with one problem. Solve it, please. It's a problem. You can try to solve it. Ketan, try to solve this one and let me know if you are able to solve it.
Yes.
Should I give the solution for this one?
I'm sorry, sir.
Okay, solve it. The concept will be used in a very basic, like we did the same in the last class also. Okay. I think it now enough time is over. So I'll take the solution. Okay, so critically this problem, you are given two lines having same mass. It's an important observation with the data which has the mass is same. We know about the density. We say have any discussion about data. Okay, the ratio of length is given as 1 into and density is 1 and 3. Resistivity is 2. It's a useful data. So let's write one by one. R1 by R2 is given as 1 by 2. Density 1 by density 2 is given as 1 by 3. So let's not mention this. Let's call density as B1, right? So this is what. And what is the next given to you? Length is also given with you. L1 by L2 is given as 1 by 1 by. If these data is given to you. Another is they are connected one by one to the same voltage supply. Make this say first, let's say this is a voltage V. Okay, so in the first case, you connected the one object. In the second, after this, after then you remove the first object, then you put the second object. That was the case. The rate of heat dissipation of the first wire was 10 watt. Find the rate of heat dissipation. So what you have to calculate? You have to calculate the rate of heat dissipation. They have not asked about the exact value of heat. Okay, they are just asking about the rate of heat dissipation. Is that clear? So if I ask what is the heat dissipation means you can call it as energy. So rate of energy is what is the rate of energy? Power. So basically they are asking about the power. So power of the first is given as 10 watt and what it will be equals to you can say the voltage is V. So V square by R. This is one data you can call. What about the next? I know that P2 will be equals to some value which I can figure out. I don't know right now. But this can be rewritten as V square by R2. Uh, so let's do one thing, divide them. So what we are going to get is P1 by P2 is equals to R2 by R. This is what we are going to get if we do this. This is what you are going to do. What else we can use? Like what else data we can have? If you see carefully, I think we don't have. Okay, sorry, this was resistivity. This is resistivity as well. Yeah, so I don't have R. What I can write it as raw 2 L2 by 8 divided by raw 1 L1 by 8. If you again rearrange, let's the whole part is of rearrange. This is power 1 divided by power 2. Raw 2 L2 will be as it is. Raw 1 L1 will be as it is. This is 1, this is 2. So again, go upside. This 1 will be go upside and A2 will go down. If you see carefully, I have this value also. I have this value also. But what about A1 by A2? If you see what is given to me is that density is 1 ratio 3, right? So I can say that density by 1 is equals to 1 by 3 is equals. What is the density? Mass upon volume, right? Mass upon volume. I can I say that?
Yes.
I think I can say that, right? I can say that. Let's take it as it is. So mass upon volume. What is volume? A1 L1. Mass is same, so keep it as it is. A2 L2. So yeah. What if you just try to rearrange it? What are you supposed to do? A2 L2 divided by A1 L1 will equals to D1 D2. Okay. So finally we can say that A1 by A2 is equals to L2 L2 D2 divided by L1 D. So just substitute this value over here. The moment you do this, raw 1 raw 2 is equals to you can see on the all of this is raw. This is power. This is raw. Okay. The difference is there. So they are not the same actually. So this is 2 by raw 1. What is the next? L2 by L1, right? That is L2 by L1. A1 by A2, what is it? L2 by L1. D2 by D. And you can see what I'm going to get is. What is raw 2 by raw 1? What is it? Raw 2 by raw 1? Okay, that is 2, right? 1 by 2. So you have to write it as into. What is L2 by L1? What is L2 by L1? This is L2 by L1, so it will come out as 2 into 2. What is this part? This is 2. So finally, what you have got, the answer is, what's the answer you have got? What is the answer you have got for this? Okay, sorry, resistivity is a principle. Resistivity is this. Why this is? Resistivity, because resistivity is given as two ratios, not one ratio. Yeah. This will be going as 1 by 1. So rho 1 is equal to 6 into P2. And what I have to call, like P1 is equal to 6 times P2. I have given a value P1. I have to calculate P2. So what is P2? Uh, P1 by 6, 10 by 6, 5 by. This is the answer. Okay, kids, know? If any doubt is there, please let me know, or else I can come up with the next problem. Any doubt, kids? Know? I hope so. So, kids, now this is the next problem. You can just try to solve this. Okay, so this is the problem. Okay, try to solve this. And let me know.
800.
How much you have got?
800.
800. 800 is incorrect. I don't know how you are getting incorrect. Wait. Hmm. Kids, there's some problem actually. If we go in this way, you want to solve any problem. Because most of the problem I'm only solving. Okay, now have you understood these concepts properly or not? This energy
Yes,
concept, thermal energy. Okay, so like, what's the problem? Why you're not able to make this problem? Okay, just explain what this problem wanted to say. What's the basic crux of this problem?
they gave the fan up to 200 volts, 500 watts for both. So calculated for 1 volt and multiplied with 116 to 12.
Okay, wait, I'm just going solution. Look, it's a here. You are given a 500 watt heater. When you say a heater is 500 watts, can you calculate the resistance for this heater? Look, I told you, Ketna, if any device is given, okay, any electrical device is given, its power is given. Okay, what meant to say power? From here, you should get to know that it is power. If it is power is given, right, in some value, if they are saying that this power designed at some particular voltage, for example, here they have given designed to operate at 200, mean to say they are giving you the specific voltage. So from here you can calculate the resistance actually. If this voltage is not given to you, what you can do, assume that they have designed it on the 220. In our case, they have given, so I don't have to assume anything. I'll simply go and say power is equal to V square by R, and what is R? V square by P. 200 square divided by power, that is 500. So this will take you something around 80 volt. What basically 500 80 80 ohms. The resistance of this heater comes out as 80 ohms. Okay? I have connected it across 160 voltage. It means this is the external voltage. There is a battery or something line of 160. You have connected this heater. Let's say this was a heater, okay, and it has some resistance. So this is a heater. It is connected. Find the heat produced in 20 minutes. So what is the heat? Heat is basically kind of energy. So energy is nothing but I square RT. Or you can say you just have to calculate heat in this if you know the voltage across it. So I can say I know the voltage across it. I can use this formula. So what is the formula? You can simply say that uh, yeah, 160 square divided by 80 into how much time it is given to you? 20. Make it 40. So what is 160? 160 into 160 divided by 40 is the answer. So this will take you around 64 maybe. 64 and 0. Yeah, this is the heat. Okay. One more thing, this is incorrect. Right now it's incorrect. Why it is incorrect? Uniquely incorrect. Okay. Whatever you have calculated, that this is calculation of 640 watt per minute. Okay. Watt minute. This is minute. Okay. We have to calculate in the second. So what you have to do is convert it into the seconds. So what is it? Yeah. If you convert this thing into the minute, what you are supposed to get? 60. You will do this and you will get the answer. Any doubt? Yeah, Kirtan, any doubt from you?
No, sir.
No doubt, right? Okay. No problem. Yeah, so this is given, you can just calculate it and get the answer if it is required in this video. Um, Anything else is this which we will not be this will give you the answer something in the that will be the I think we can move to the next topic. Okay, Kate, now look, what we can do is instead of solving one problem each and each, I'll give you two problems. Okay, just solve this. It's going to be whatever it is.
There is a case where the team to ask.
Kirtana, have you understood this solution?
Yes, sir.
My mic was muted. I just forgot that my mic is muted over here. Okay, Kirtana, why we did this step? Can you just please explain this part?
They also totally.
Okay, let's do one thing, Kirtana. What I'm going to do is, Kirtana, I have solved the whole problem. Now. Please get me the answer finally and give me this. Share me the solution first, okay? Solve it. Okay, take a photo of that solution. Share in the chat. I want to solve. I want to check it because I have just given you the complete solution for this. So I hope you can make it.
Yes, sir.
Uh, yeah, Kirtan, are you sorry? Or Max, please let me know. Kirtan, okay, I'm giving you one more problem. You can try to handle problem. Hello, Kirtan, are you there?
Yes, sir, I'm done with the problem.
Okay, you are done. Just solve it fast. I have to take the next class just now at 7:50. Okay, let's do one thing. We'll discuss in the next class. Okay. I'll take another class, so I'll end this session by now. We'll do one thing, revise everything, whatever we have discussed till now. In the next class, I'll be going to the new concept that is power, okay, minimum power theory. And after this particular portion is complete, we'll move to the answers.